So, hello students. Good evening to everyone. How are you? Doing good or great? Okay. So make sure the screen is visible to you and I'm audible to you. Okay. Just give me the thumbs up as I have enabled it for you. If the screen is visible to you and I'm audible to you. Each and every one of you. Okay. So here we are, our lecture number 5 for gravitation. Okay. We have covered 4 lectures in the series of gravitation. Okay. I am not letting any information to be hold for you. Okay. I am going deep down to the concepts because it is very essential for you guys to be focused on the concept rather than the facts. Okay. So we will wait just for 1 minute more. Let the others to be joined. Then we will start. So how's your preparation is going on? Like gravitation is understandable, na? Are you finding any trouble in solving the numerical problem? Bhavna, Rajesh, Mamta, Anjana Shri. So question solve हो रहे हैं? Any kind of help you need, you can write it in the chat box, no? Okay. So it's all about the question you solve. The how much practice you have did. The exam is based on that. Okay. So I think we should start the lecture. Okay. So firstly, what is in this for you? The aim for today is to recall some concept. Then we will deal with the effect of gravitational acceleration due to Earth, like the shape of Earth and the rotation of Earth. Okay, this has been left over from the previous class, so we will discuss it here. Okay. After that, we will going to discuss about the gravitational potential energy, which is the first most important concept of this chapter. I'm saying this first, so there would be a second also, which is the gravitational potential. Okay, so this we are going to discuss today in a very detailed manner now, and we will also see some numericals which is not mentioned here. Okay, now then move on to the lecture. Let's just get started with it. So for recall part, we have did the derivation of gravitational field intensity due to disk and due to ring. We have already discussed it in the previous lectures. Okay, so gravitational field intensity due to disk is nothing but I is equals to 2 pi sigma g, capital G, which is the universal gravitation constant, into 1 minus x over square root of x square plus r square. You do not confuse it, because in the previous session I have written it like 2 pi sigma g x into 1 upon x minus 1 upon uh, square root of x square plus r square. Okay, so do not confuse with it. Got it? We have just multiply the x inside, so it will become I is equals to 2 pi sigma g 1 minus x upon square root of x square plus r square. Okay, got it? So this is the formula that we have learned how to derive it, and do that the derivation part now. Do it like 3 to 4 times. At least 2 to 3 times you have to did it with your own self. Shut down your the notebook, take your rough book on which you are solving it, and shut down all the resources that you can take help, and just derive it by yourself 2 to 3 times. Okay, then you will have a solid grasp on the concept. Then we have discussed about the gravitational acceleration, because earth is pulling everything towards its center, and this pulling is nothing but a force applied by the earth, which is the gravitational force. So when we apply a force on any system, if this is a system and if we apply a force, so there must be a possibility that this system would accelerate according to this equation. Okay, so if this is the earth and this is some object like say smaller mass m, and the mass of earth is m, so what is the force applied by earth on this object? It is g MEM over the distance between them. Let the distance between them is r, small r square, which is equals to, on which we have applied force, on this mass particle small m, into acceleration. So m and n got cancel out. Acceleration we have as, we can represent this acceleration as g. Acceleration we have as gme over r square. You can clearly see here that this gravitational acceleration will independent of the mass of the system on which we have applied the force, which means you can take a 10-gram ball or a 100 kg stone, and if you throw them in vacuum where there is no air resistance, so they will come down at the same time, because the gravity attracts anything without any kind of bhedbhav, without any kind of discrimination. Okay? So earth behaves with everyone with the same way, which means it attracts everyone towards the center of it with the same gravitational acceleration, which is gme over r square. Okay? Now the gravitational acceleration above and below the earth's surface. I think you have must aware about the formula, that is g dash is equals to, for above part it is for the above one, so g dash is equals to g into 1 minus 2h upon re. When you take any object at a height h from the earth's surface, then what will be the resultant gravitational acceleration that will be acting on that particle will be g dash is equals to g times 1 minus 2h upon re. If we talk about the below one, so it is g dash is equals to g into 1 minus d upon re, where d is the depth. So if you have an object and you dig down to the earth surface and take it to the at a depth of d, then the resultant gravitational acceleration there will be g dash is equals to g minus g into 1 minus d upon re, which is probably reduces, which means if you goes up or down, in both the cases the gravitational field acceleration decreases. So what is the maximum value of it? The maximum value of gravitational acceleration occurs at the surface of earth. Okay, then if you goes up, the gravitational acceleration decreases, and if you goes down, then also the gravitational acceleration decreases. And when it becomes zero, the gravitational acceleration becomes zero at the center of earth. Like this is the earth, so at the center of it the gravitational acceleration will be zero. Okay, so at center g is equals to, say, got it? I hope you are clear with this. This is just the formula, the concept I have taught you earlier in the previous lecture. Now the effect of gravitational acceleration due to earth. So there are two factors which can disturb this. First is the shape of earth. The earth is not a round object. It is a kind of oval. Okay? And why is this oval? Oval क्यों हो रही है ये? Anybody has any idea about it? Why our earth is not round? Why it is oval? It is because the spinning part of it. It is rotating about its own axis. That is why the parts present here at this point, suppose if this is a circle, so at this point wants to be, there is a centrifugal force applied on this part, so that is why the shape of earth has been disturbed. Okay, because these parts, the side part wants to come outward from the, wants to come away from the center, so that is why the shape of earth will be a oval shape. Got it? Because these part, the side part wants to move away from the center of earth because of the gravitational pull. I'm writing it here. The earth is oval shape. The disturbance of shape of earth is occurred due to its rotation, due to rotation about its own axis. Okay, so it is because of the rotation about its own axis. That is why, because because of this rotation, there is a centrifugal force acting on the earth surface. Okay, now the variation of g due to earth shape, how the gravity will be affected by this shape of the earth. It is very simple. We know that we know that the gravitational acceleration g is gme, the mass of earth, divided by the radius of earth squared. Okay, now let us understand it very clearly. The radius of earth is measured from the center of earth. Okay, so these points are the poles poles of earth. Okay, and these points here is the equator. Okay. Now, when you move towards the pole, you will see this is a shape of like this. So from the center, if you move in this direction towards the pole, and if you move towards the equator, so the distance moved towards the pole and the distance moved towards the equator is not same. The distance moves towards the pole is less than the distance moves toward the equator. And it is nothing but the radius is varying. This is the radius of Earth, which is varying from pole to equator. And how? We can say that the radius of pole, radius at pole, which means the radius of Earth at pole, is less than the radius of Earth at equator. I'm writing it EQ because RE is the radius of Earth. So to remove this confusion, I am written this as the REQ, which is the representation of equator's radius. Okay. Because of that, you can say that the G at pole is equals to GME divided by RP square, and G at equator is equals to GME divided by R at equator square. You can clearly see this G from this equation. You can say that this G is directly proportional to 1 by R square, which means if you increase the value of R, if you increase the value of R, the value of G will be decreased. Okay. And you know that if you take the ratio of these GP by GEQ, GP by GEQ is equals to GME by RP square divided by GME divided by REQ square. This GME and GME will cancel out. This REQ moves to the first place. Okay. So it is REQ square divided by RP square, which is GP divided by GEQ is equals to REQ divided by RP whole square. From this equation, from this relation, RP by RQ, RP is less than REQ. So if you take this as REQ by RP is greater than 1. Okay. I have taken this RP to this side. So REQ by RP is greater than 1. So this ratio is greater than 1. So the square of it will also be greater than 1. So you can say that this GP divided by GEQ is greater than 1, which means the gravitational acceleration at pole is greater than the gravitational acceleration at equator. Okay, got it? So the gravitational pull at pole is greater than the gravitational pull at equator. Got it? So that is why all the launches of satellites will be from the equators nearby, not at the pole. Because if you launch the satellite from the pole, it will have a greater pull towards the earth. So you need to expend more fuel. You need to spend more fuel onto that to recover that. So to avoid that, we launch the satellites to the equator. Suppose you are the scientist and you want to the launch it. Okay. So which site you will use? You will use equator now. Okay. Because the gravitational pull is less here. So you need to spend less fuel than the poles. Got it? So the gravitational acceleration at pole is greater than the gravitational acceleration at equator. I am telling you that the radius of pole, radius of equator is around 32 kilometer greater than the radius at pole. So there is a difference of 32 kilometer. Got it? This 32 is in kilometer. Got it? So if you are having any doubt in this, you can just write it in the chat box. Then we will see the next concept. Now the variation of gravitational acceleration due to rotation of Earth about its own axis. So suppose the Earth is rotating with an angular velocity omega about this axis. This is x-axis, this is y-axis. Okay. Now, if a particle is present here, it is also revolving around this circle because Earth is rotating. So any point present on Earth is also rotating in this type of motion as we are. So this is the path of rotation of this point. Okay, got it? So due to the rotation of Earth, this point will feel a gravitational pull because in circular motion, there is always a centripetal force acting towards the center, Fc. So it will also feel a force Fc here. Okay. If this angle is theta, so the gravitational pull, which is mg, the gravitational pull force is mg, gravitational pull by Earth is equals to m into g, which is acting towards the center of Earth. So this is the direction of that. But due to the rotation of Earth, there will be an extra force, which is Fc towards the center. Okay. If you sit in this frame, okay, if you sit in this frame, so you will not feel this centripetal force. Instead of that, you will have a centrifugal force, which is mr omega square. Okay, you have know this value from the previous chapter. This is work, energy and power. Okay, or the dynamics of circular motion, you will have this value. Got it? So from this you can say here that the net the net gravitational acceleration, the net gravitational acceleration which is felt by this object, which is us, is in the resultant of these vectors, which is slightly away from the center of Earth, which is mg dash. So this is the effect on gravitational acceleration due to the rotation of Earth. So if you calculate this value by vector addition, because this is the resultant, and here are two vectors you have. If this angle is theta, so this angle will also be theta because there is a Z formation. This angle is 90 minus theta, or you can say this angle would be 180 minus theta. Okay? This is the situation. Here the mr omega square. Okay. Here is the mg, and this is the resultant. Let's say here. So if this angle is theta, What is the angle between these two vectors? It is 180 minus theta. So resultant mg dash here is equals to square root of, what is the resultant? Firstly, I will write that formula. So resultant vector magnitude is given by a square plus b square plus 2ab cos of theta. Okay. So we have a as mg, b as mr omega square, and angle between them is 180 minus theta, not this theta. The angle would be taken in between the vectors. Okay. So resultant will be mg dash is equals to mg whole square plus mr omega square whole square plus 2 times mg mr omega square, and this r is nothing but the radius of earth, into cos 180 minus theta. Okay. This 180 minus theta, cos 180 minus theta is nothing but, just a second, cos 180 minus theta is nothing but what? Cos 180 minus theta is minus 1 minus theta, because 180 minus theta lies in the second quadrant. In second quadrant, the cos will be negative. So cos 180 minus theta will result in minus cos theta. Okay. These are the some values of it. Let me just check with it. So what is the relation finally? It is mg dash is equals to mg square plus mr omega square whole square plus 2 times mg into mr omega square, in, or this plus would become minus cos theta. Okay, got it? So you can say that here in this expression mg dash is equals to m square g square, it is mr square omega raised to the power 4 minus 2m square gr omega square cos theta. So from this equation you can say that this omega square, r square omega square, will be a very short term. Okay, so you can neglect this in respect to this mg square. Okay, so you can neglect this term. So neglecting r square omega raised to the power 4. Okay, so this term will vanish here. Now the expression that you will have is mg dash is equals to square of mg square minus 2 times m square r omega square cos theta. Okay. Now, if you take the square of both sides, it is mg dash whole square mg square minus 2m square r omega square cos theta. Take the m square common and cancel it out. So you can cancel it out here. So it is g dash square is equals to g square minus 2 times r is equals to nothing but the radius of earth, 2 times re omega square cos theta. Okay. Now, one thing you can do here, you can take this g square as common. So g dash square is equals to g square if you can take common. So it will become 1 minus 2 times re omega square divided by g square cos theta. Okay, got it. Now take the square root of it. So g dash is nothing but this g would come out of the square root, and this will remain as 1 minus 2 times re omega square g square cos theta raised to the power 1 by 2. ठीक है. Okay. So this r here is nothing. R here is not r only. You can see here, this r is the radius of this circle. Okay. And if this is r and this angle is theta, so this would be r cos theta. So we would put r is equals to re cos theta. And if you put it here, this will become cos square theta, and cos square theta. Now, by using binomial theorem, we can expand it. And since the higher powers will have no effect, so we can neglect them. So g dash here is nothing but g into 1 minus 1 by 2. The power will came out here into 2 times re omega square by g square into cos square theta. Okay. This 2 and 2 will get cancel out. So you can say that g dash is nothing but g dash is nothing but okay. So when you have taken out g square as common, so there will be a term remaining here, which is 2 times re omega square g square. Yeah, everything we have done correctly now. Let me just check with it, because I think there is some mistake in this with this square term. Let me just check with it. Okay, so it is m square g r omega square. So here we have missed this term g. You guys are not paying attention to this, no? No one of you have reminded me this, that we are making this mistake. So when you taken out this g square common, so only g will be there, not g square. So this will remain as g. Okay. So g dash here is nothing but g into 1 minus re omega square cos square theta divided by g. Multiply g the inside. So g dash is nothing but g minus re omega square cos square theta. So this is the effect of the rotation of Earth on the gravitational acceleration. Okay. Note this expression. Then we will move next in the lecture. Okay. So the expression that we are up with is g dash is equals to g into 1 minus g minus re omega square cos square theta. Okay. So if this theta is nothing but the angle measured from the center of Earth, Suppose this is the point P here we are talking about. This is angle theta. So if this angle is theta at equators, at equator, this theta is equals to 0. Put this value, we have g dash is equals to g minus cos 0 will be 1, which is the maximum value of cos that can attain. So it is re omega square only. So the maximum we are subtracting from this original value. So it is the minimum value we are getting. So at equator, the minimum value of gravitational acceleration we will have. But at the pole, at the pole, the theta would become, to reach the pole is here. So theta would have to become 90 degree, and cos 90 is nothing but equals to 0. Okay. So this g dash is equals to g minus g. G dash is equals to g. So the maximum value we are having at the pole. The maximum gravitational acceleration we will have at the pole, and the minimum we will have at the equators. Okay. Now, this question I have to discuss with you. A spherical planet far out in space has a mass capital M and diameter capital D. A particle of mass m is falling freely near its surface. Then what will be the acceleration of that particle? Okay. And we have to calculate the value in terms of, this capital M and capital D. Okay. So let us try to solve this question. Solution of this question is, so there is a spherical planet far out in space, has a mass capital M and diameter D. So mass of the planet is capital M, and diameter of planet is equals to capital D. Now we know that the gravitational acceleration provided by any planet, let's say it is Gp for the planet, is nothing but g mass of the planet divided by the radius of the planet square. Okay. This is the gravitational acceleration which is applied on this small mass particle. Suppose this is the capital M mass planet and this is the small m. So it is pulled towards the center of this planet. Okay. With an acceleration of gmp divided by rp whole square. Now we know that this rp is equals to d by 2 because the diameter of the planet is d, which is half of the radius of planet, and mp is nothing but capital M. So gp, you can say that gp is nothing but gm divided by, what is the value of rp? It is d by 2 whole square. So gp you have as gm divided by d square by 4, which results in 4 gm by d square. Okay. So this is the acceleration that would be felt by this planet, that would be felt by this object of mass m. Okay. I hope you are clear with this concept. If you have any kind of doubt, you can ask. Now, move on to the next question. So here, in this question, firstly, we will write what is given to us. So in this question, if the ratio of masses of two planets is 8 by 3 and the ratio of their diameter is 2 by 3, then what will be the ratio of acceleration due to gravity of that planet respectively? Okay, so here we are provided with these accelerations, sorry, these ratios, and these ratios are nothing but the ratios of mass and ratios of diameters. Let's say let's say consider mass of masses of the planets. Masses of the planets are m1 and m2, and diameter diameter of the planets are d1 and d2. Okay, so what we are provided, we have provided that the ratio of mass m1 by m2 is equals to 8 by 3. Okay, and the ratio of diameter d1 by d2 is given as 2 by 3. This d1 and d2 you can further write it as r1 by 2, sorry, 2 times of r1, the radius of the planet 1, divided by 2 times of the radius of planet 2, 2 by 3. This 2 and 2 will get cancelled out. So you will have r1 by r2 as 2 by 3. Okay. Now, what will be the ratio of acceleration due to gravity has been asked. So gravitational acceleration is nothing but g mass of the planet multiplied by the radius of the planet square. Okay, so this formula we are going to use. Now, for planet 1, let's say the gravitational acceleration is g1. So we can say that it is gm1 square, sorry, gm1 divided by r1 square. Okay, the g2 for planet 2, this is equation number 1. For planet 2, it is g2, which is gm2 divided by r2 whole square. Okay, if you take the ratio of equation 1 and 2, take ratio of equation 1 and equation 2. So what do you have? You have g1 by g2 is equals to gm1 by r1 square divided by gm2 by r2 square. This r2 will multiply with gm1, this r1 will multiply with gm2. So what do you have? You have g1 by g2 is equals to gm1 r1 r2 square divided by gm2 r1 square. This g and g get cancelled out. Okay, now g1 by g2 is equals to, let me change the color of pen. G1 by G2, we have come with gm1 r2 square divided by gm2 r1 square. Okay, this g and g get cancelled out. We know that m1 by m2 is given by 8 by 3, and radius, the ratio of radius r1 by r2 is 2 by 3. So G1 by G2 is equals to what? M1 by M2 and R2 by R1. Oh, but here we are provided with the value of R1 by R2. So you can take it as R2 by R1 is equals to, just reverse this. Okay. So it will become 3 by 2. Now put this value in this equation. So G1 by G2 is equals to M1 by M2 is 8 by 3. Multiply with R2 by R1 is 3 by 2 square. 3 by 2 whole square. Now G1 by G2 is equals to 8 by 3 multiply by 3 by 2 whole square. G1 by G2 equals to 8 by 3. 3 square is 9 divided by 2 square is 4. 4 to ja 8 and this 3 to 3 ja. So you have G1 by G2 is equals to 2 multiply with this 3. Okay. So G1 by G2, finally you will have G1 by G2 as 2 3s are 6, which means G1 is equals to 6 times of G2. Or in terms of ratio only, if you want to calculate the ratio, so it is G1 by G2 is equals to 6 by 1. Okay. Which means the gravitational acceleration of planet 1 is greater than the gravitational acceleration of planet 2. And in numbers, if I talk about, it is 6 times the gravitational acceleration of the planet 2. Okay. I hope you are clear with this concept. So here the G1 by G2 finally we will have as G1 by G2 we have as 6 by. So the correct answer is 6 by 1. 6 by 1 is the ratio of 6 by 1 is the ratio of the gravity acceleration due to gravity. Okay. Okay. So in this case also you can, if you focus on this case, you will see here this mr omega square will came into contrast. Okay. This mr omega square, for any circular motion, there will be a force which is mv square upon r towards the center, and this force is termed as fc, which is centripetal force. Centripetal force having a magnitude of mv square upon r. We know that we know that we know that this v is related to the angular velocity. Suppose the angular velocity of this object will be omega, so this is related with the angular velocity as v is equals to r omega. So if you put that v is equals to r omega in this expression 1, so it will be fc here will be m r omega whole square divided by r square, and this you can also take it as capital R. Okay. So it will result in m capital R square omega square divided by r. You can cancel one of the power of it. Okay. Now Fc here is mr omega square, and r would be considered the radius of the circle on which it is moving. Okay. But what if I sit on this circle and watch the motion of that object? If I sit on that object which is moving into this circle with an angular speed omega, so what would be happen? This block will seems to me be stationary. So this block will be stationary. But we know that there is a centripetal force acting on this direction, which is mv square upon r. And if this block is not moving towards the center, so there must be a centrifugal force just opposite to that, which is F centrifugal. Okay. That is why in this scenario of the earth rotation, earth rotating about its axis, and we have taken this point and it is also encircling something. It is moving also in a circle. That is why I have considered that this point is not moving away from the earth. So there must be a counter force, which is F centrifugal. Centrifugal. Okay, got it? So this is the point I want to tell you about this derivation. I hope you are clear with this. So in the next lecture, we will deal with the potential energy of gravitational potential energy, and we will definitely see some numericals on it. Okay. Thank you so much for being attentive in the lecture. Thank you so much. Take care of yourself. Have a good day. Thank you so much.